Hello. Cheers, everyone. Hi, everyone. So we're having a few technical difficulties. Marius is almost ready to come in. He's just got to install some drivers on his computer. This camera's doing some weird lighting things. So my preview, just letting everyone know, sorry, a lot of technical difficulties this morning. My preview in YouTube is showing that the stream is not going, but it looks like it is in chat. So fingers crossed, this is all working. Can everyone hear me okay and see me okay? It is going. It is excellent. Okay, fantastic. Oh, wow. Okay. So the stream is perfect. Thanks, Julian. It's perfect because you're here. So, okay, maybe while we're waiting for Marius, I will say hi to everyone in the chat. Graham, good morning. Cable Tie, hello. Mike, hello. Hope you guys are appreciating the later start. I know I am. Getting to sleep in an extra half an hour is nice. Johnny, hi. Bruce, hello. Bruce was telling us about the story about how he's lost some of his finger. And he's... Photocomax, hi. Carsten, good morning. Rota, hello. Julian, hello. Adam P, hi. Hello, Chris. I am live and I am alive. Hello, Dave Hines. Hello, Nick. Mike, Andy Mouse, Ray, Zoom. Are we having fun yet? Never having fun on my channel. Paul, hello. X-Micron, hello. Henrik, hi. I cut into my third meal too. What? Hybotics, hello. Okay, I think I got everyone for the moment. For those that are on my patrons, they would have yesterday I let them know that I burnt my hand with a boiling jug of like a kettle. So I've taken the bandage off. You can see it's a bit, I've got a few burn marks on my hand. I poured half a kettle of boiling water on my hand. I did it in the start of the day, and it kind of wrecked my wrecked the day of what I could do. So on my video yesterday, I had it bandaged, and I had like this burn gel stuff all over it, and some gauze on it. And look, it's okay. I can move my hand. The skin's a bit tight. It's a bit tingly, sore, but the blistering is minimal, which is really good. I got it straight under cold water. So yeah. Lucky it wasn't my good hand. I don't have a good hand. They're both bad hands. So yeah, but that's okay. It would have been much more interesting if I burnt it doing some maker stuff, right? But it was a kettle. It was a lack of concentration. No, I'd already had a coffee. I was making a hot chocolate for Yuz, and I got distracted, and I looked away, and I went to grab the cup, and the cup didn't. It's kind of suctioned to the bench a bit, and so when it didn't lift like I thought it was going to, so then my hand jerked, and the kettle I was pouring, right, and it went over my hand. Anyway, yeah, one day, was it time since last accident? One day or zero. Well, wouldn't that rip your 90? What? What the? Hey, Bitloony. Hey, Cape Cad. Hi, Kai. More people in the chat, which is cool. Hey, Wagon Loads. Yeah, that was good. That was on Kyle's. Yeah, yesterday Kyle did a live stream. Kyle Hunter from Microtype, and yeah, the whole stream was helping him diagnose and fix a buck converter board. It was pretty good. I was watching. I wasn't offering any help because I came in late and really didn't know what was going. Okay, I'm going to try to add Marius in. He says he can't hear me, though. Okay. Oh, and I went to add him, and he disappeared. So I can't add him. Okay, we're going to have some technical difficulties today. There we go. So his issue was from listening to someone's suggestions on a previous stream. Okay. Oh, Marius is back. So we're going to try this, folks. It's going to work or it's not going to work. Here we go. Hello, Marius. Can you hear me now?
I can hear you. Can you hear me?
I can. Hi.
Oh, finally. Hey.
You're in a dark cave again.
This is low pixel, Marius.
Low pixel. Yeah. So the stream's only 720p, folks. It's StreamYard. I went to upgrade StreamYard actually yesterday. I thought if I'm going to do more, guest appearances, I might as well get, my upgrade. And they've now got 2 tiers, and the other tier that they used to have that upgraded to 1080p doesn't upgrade to 1080p anymore. Now you got to get the second paid tier, which is like $800 a year or something. And yeah, I'm not going to pay $800 a year for the 4 or 5 times a year I might get a guest on. Anyway, sorry, everybody. It's Marius. Marius, you want to introduce yourself?
Hey, I'm Marius Heier, or from the Netherlands. No, it's actually in Norway.
Sorry.
I'm a 40-year-old man, or I think it's better when people call me Guy. I think it sounds younger. Yeah, You've previously had a bunch of different jobs. My previous job, I used to be like an executive within a gigantic energy company in Europe, where I worked with a internal startup that we made in the company, and after that, trying to start something really difficult inside a giant corporation was really hard, because we're kind of trying to do something hard and at the same time need to play all the politics and all that game. So it just got too frustrating to continue to do that, and I just started to try to start something for my own, and that's 3 years ago. So
okay, so you left there and then you started tinkering.
Yeah, I've been tinkering all my life, basically, with most things. And I think after I discovered MicroPython, which was like about a year after I started to do any Python, I was like, oh, this is going to be big. This is just going to change everything. Suddenly I can code hardware, which is insane. And it kind of just went on from there. And I just wanted to see what opportunities this could give for the future, and it just made sense to jump off the bandwagon of great success and the corporate life to just try something more meaningful.
Right. So you're a risk taker.
I would say so.
You know that well.
Yeah. I spent like half of my life trying to make a lot of money, and finally when I got like a position to do that, I figured out that that wasn't so cool after all.
Yeah. There was
just having freedom is what's cool.
Yeah. It's different stages of your life as well, right? For a long time in my life, money was the thing. It was the goal, right? The goal was the make lots of money, because then you can, forget about the whole money and happiness discussion, but it was about, acquiring wealth to have opportunity when there's opportunity to be found, when totally regardless of money, right? And passion end up being way more important than money. You have a whole pile of money sitting there and no passion and no motivation, and it's pointless, right? And if you've got passion and motivation, you always find a way to push through, even if you don't have money. So
yeah, exactly. So if you see, like, if you even look at like the most rich person in the world was now, I believe, is Elon Musk, right? So it seems like he's living not a pretty happy life. Even though he is very rich, he is very attached to whatever his agenda and all the things. He's not a free man.
Self-inflicted, but not a free man, absolutely. But he's got a very clear focus though on what his aims are. So that's that's kind of unique. Like he's
maybe,
or maybe,
yeah,
not necessarily how to get there, but Anyway, okay. Let's not talk about Elon. I think that's going to be a love-hate thing in the chat, possibly. So I just want to say hi to some more people. Hey, Shaq, how you doing? Hi, Peter. Hi, Matthew. For anyone I haven't said hi to, I apologize. Did you call? Hello. Welcome. So, Musk groupies going crazy. Yeah, no. Let's stay away from the Musk discussion.
Yeah. I'm still a big Musk fan.
Yeah, so am I. As am I. Some of his antics are a bit. It could be done without, but his overall, there's more good than bad. Some antics, but rich is not wealth, just a bugbear. Sure.
Yeah, exactly.
Mike wants to know what time it is for you right now, Marius.
It's 10:15 in the evening.
In the evening, yes.
Or in the night, or
it looks like daylight for you guys outside right now. In your cave.
It's always dark in here.
It's always dark. Actually, I said to Marius before the stream started, I said, turn your lights on. Like I couldn't even see his face.
Yeah, I had like all my lights on.
The whole house lights are on right now. It's just that in Norway, they just don't have a lot of electricity.
No, it's just like dark. So in the winter, you wake up in this dark, and you come back from work, and it's dark again, right? So
you never see daylight.
No.
Yeah. That's a bummer. So, okay, let's talk before we get into the meat, the good stuff. Let's just, let folks know that are watching what type of maker stuff you've been working on. Like, what type of stuff have you been doing? Like I know what you've been doing. I don't want to tell them. I want you to tell them. Or do you want me to tell them?
Yeah, so I kind of spent 3 years trying to figure out what I should make. So obviously I'm not necessarily only driven by whatever theme seems cool to make. So I think I need some kind of like lower code motivation for driving the stuff I'm going to work on and do. And I've been basically trying to figure out what is this new thing that we're all a part of, and especially you, which is going on now, right? With so many people getting into electronics, possibilities of ordering very low volume things, all this open source stuff. What is going to be kind of the things that will come out of all of this? And also, we've been also really wondering, kind of just like looking under turtle by turtle. It's like, okay, so is there something exciting here, or should I just like look a bit deeper? Right. So I've been obviously needed to learn a lot more about electronics when I started 3 years ago. So I did only like 1 year of electronics as part of my education.
Okay.
But I've always been into electronics and computers in general. So trying to just to build boards, and I guess as many also listening right now has probably been diving deep into your tiny Pico source file and watching and trying to learn how it all works. Maybe just building their own version. Yeah, exactly. Like, and the same with Adafruit, right?
Yeah.
And that's what's like this really exciting about this, is that like you don't need to do that much other than just share your work in any way, right? Even if you just share your work on GitHub, there's someone that's going to read that code, and that's going to help someone. If you make videos, instruction stuff, there are always someone who will read all of that stuff too, and it will kind of build on top of this huge knowledge base that we're building in. And I really think that there's something really big that will come out of this whole maker movement thing.
Yeah.
And I really think that it can really do something. It's like when we look at the world how it is today, it's many people are really probably not satisfied the way the status quo is, right?
Sure.
And I guess that goes for most people in the world, probably. I'm not sure. It's it's really interesting to see where this is leading. So let me just go back to your starting question.
Right?
Yeah.
Like you've got a wealth of knowledge that's being shared and built upon and reshared and built upon, which is enabling people to learn and do things, and not just electronics, use their hands where they wouldn't have in the past, and understand how things work when they wouldn't have in the past, and then maybe make things and manipulate things and fix things and experiment with things, and and spreading not just electronics and more high tech stuff, but the other direction as well. Like the amount of woodworking channels on YouTube are just insane, right? But the amount of things that you can learn, and then the people go and do stuff, like people go and build their own homes, and like I don't know if you watch any of Peter Stripol, that's how you say his name. Like he's like he basically shows people how to build airplanes, and then people go and build airplanes. I mean, there's never been a better time to learn and how to do things, and then be able to actually access what you need to do those things, right?
Yeah, exactly. So let's so I was thinking, should I start to make products same as you do? Should I start to make boards? But what I kind of landed on is that obviously it seems pretty hard to do this electronics production stuff, right? But I'm thinking that if many people are able to make boards themselves, and not necessarily manufacture them, but at least make them at home, then that will enable hopefully I believe like some kind of content creator market for electronics, right? So if everyone has a machine or machines or just instructions on how to put things together, then you can move to a more digitally based product space, right? And your hardware products will be way more similar to software, where basically the hardware product you have is just like a snapshot of what that source code was at a certain time when you built it, right? And I think it's really interesting also to look at 3D printers, where you see like some of the best amateur 3D printers are the open source ones, which is never done. There is continue to be worked on all the time by like a small team. So I think that we'll move to this kind of products in more spaces. It's just natural to have it in 3D printing, because everyone which has a 3D printer can just make another 3D printer, right? Almost.
Sure, rep stuff, absolutely. Yeah.
Yeah.
I mean, the barrier to entry on building electronics is dropping, right?
Exactly. Yeah.
But you're talking about beyond, like, I mean, right now anyone can get a proto board or a breadboard and design something and build something, right? They can access the parts, whatever. I mean, there's still a barrier if you want to go to a PCB, in that you have to actually be able to make the PCB, right? Forget about etching and stuff. Like, I think we're a very long way away from getting, a desktop printer that you push a button and a PCB comes out. But there are machines kind of like that, that are very expensive machines. But that is, maybe that'll take a lot more time. But you're talking about the whole, I'm going to make a board at home. I'm going to make one. I'm going to make 5. I'm going to make 10. I'm making them for myself, or making them for my friends, or I'm making them to sell, right?
Yeah, exactly.
And that has already dropped. The barrier of entry for there is already dropped, but it's still expensive, and you still have to take some risks and invest some money. Even if you're buying a cheap DIY pick and place machine and a manual stencil printer and whatever, like there's still costs and process involved, right? So you're talking about having those things become more mainstream and simpler and accessible.
Yeah.
Right?
Yeah, exactly. So I was also thinking about, making like a company which could make machines. But I think it's, that might be interesting for some, but I think that you will kind of fall between two chairs in terms of what you're able to make. And I'm based in Europe, we're not in the EU, but it's almost as we are in the EU, and there's so much regulations and stuff that's just hopeless. So I think it's very simple. I think like the solution on what I feel I can contribute with, it's just like putting myself in the position of making electronics, see what is hard to do, and just work on that. And just look at everything with fresh eyes, and always remember to try to make things simple, and not kind of like engineer the heck out of everything, which is very easy and very satisfying to do. And obviously just share as much as possible, because the thing is that when you start to share, you'll get feedback from people, and people will start to copy you. And eventually, if you only have like 10 subscribers to your YouTube channel, your videos and the stuff you do will kind of be mimicked probably by them if you're working on something interesting. And that stuff will accumulate over time. So that's why my heart as this very simple, like this solder stencil box thing that we've been working on, because that's obviously something that I find hard, and that has messed up a lot of boards. Obviously. And it's like,
I was going to say, okay, so I mean that kind of leads us into, so I'm not sure if people have seen the video of the machine that you made, the actual stencil printing machine. So you made a comment then about, should I start a company that makes machines, right? The interesting thing there is, like, I never wanted to start a company that made that manufactured boards. Like my aim was never to be a manufacturer per se. My aim was just to design and make stuff and hopefully make a living, support myself selling some products, right? If I could take the I'm a manufacturer, I'm not talking about outsourcing, but if I could take the I'm a manufacturer away from that, then things would be nice, and I'd be having fun every single day. But suddenly you find yourself in the manufacturing side of the business, which is not fun, but it's a necessity. Right. The flip side is you don't ever make the stuff. You design the stuff and you let other people make the stuff, which is what you're talking about. Right? It gives you a sense of freedom then, because it's about refining the item or improving the item, but not having to then retool and remanufacture the item. Or when do you go to market and how do you go to market, and all the things that become business decisions as opposed to creative decisions. Right?
And it's like there's also a lot of responsibility when you release a product. Obviously, it's less It's not less responsibility. It's just like less risk if you make like a maker product, right? But if you manufacture, or if you make like a full normal product with a white shiny box and plastic and all that stuff, there's just so much unnecessarily risk that you need to cover, which drives the cost absolutely insane in terms of what the value of the actual product is. And I believe that lowering this risk is extremely important for innovation, and just try to be able to release as many products as possible. So I think it's extremely interesting when you look at all the reference designs for all the semiconductor companies. It's like the thousands and thousands of products which you can basically buy of DigiKey or something, right? But it's not in a nice white box. It's just like a circuit board, but it's almost ready, right? So if you had a 3D printer, you could probably just make like a box of tons of products that you wouldn't have even access to, and it's just like I think like a place to start is to just start with this thing which I find hard, which is doing solder stenciling with low risk. So and
didn't start easy. So okay, so back to what I was going to say.
Yeah, I didn't start easy. Yeah,
I've seen the video of the machine that you built, which got my interest. I mean, we'd been chatting before that, but got me really interested in what you were doing when you. So Marius built an actual stencil printing machine using, you know, like an XYZ gantry and rotation, and the PCB gets automatically pushed in place and the stencil comes down, and then you can use a PS4 controller to align the stencil, and you're also working on optical recognition for stencil alignment and all these things, right? And it was turning into a really complicated machine.
Yeah,
and it was really cool, like really, really cool. And so obviously you were reinventing a stencil printing machine when there were stacks of stencil printing machines already out there, right? And sure, you were making something that other people could replicate. I get that.
Yeah.
But then you stopped with that, right?
Yeah. Yeah, it was kind of hard. It's always hard to drop things that you like, which is interesting, right? Because there's always this line between being self-motivated by stuff and just like doing stuff that you find unnecessary, if you know what I mean. It's like obviously more intriguing to make like a 5-axis CNC controlled machine than to make like plastic box, right?
Absolutely. Right. But you started with I have a problem. Can I improve this? Right.
Yeah.
Which then turned into I'm really interested in, you know, mechanical and you know, steppers and controllers, and I want to see if I can do all this in Python, and I want to see if I can control it like this. And suddenly it became a project where you were experimenting with ideas around stencil printing, right?
Yeah.
But you kind of, which is great. I love that. Right? That's how you learn. But you kind of lost the way on the stencil printing because it became about the machine.
Yeah. Yeah, exactly.
And then all of a sudden now that's off to the side, and you've made this really simple stencil system, right? Yeah.
And so there's also like a pathway between like being able to make this 5-axis machine. Like I think it was coded in like a couple of days. So like the reason why it was possible to code this in a couple of days was that I was just coding in normal Python.
Yep.
And just controlling the stepper motors from, you know, Python code.
Yep.
Python 3. And just directly manipulating the registers on the motor controller chips from Python via USB. And that's like, that's pretty interesting. And that, you know, and then I dove into the whole field of motor control. I'm still there. That's kind of like my dessert to work on this. Like I got an email from Texas Instrument, like a newsletter today. They renewed some of their BLDC stuff, their brushless motor drivers, and I was like, I want to look at this, but I should finish the box. The box.
There's always a pull between shiny new things or things I want to play with and continue on, and I need to get this finished, and I want to do this. Like I'm pulled every day in many different directions. Right.
Yeah.
So the thing I wanted to get you on the stream and chat about is why, like, so it's no secret for all my, you know, community that I constantly get, I won't say harassed. Harassed isn't the right word. I get, what's the word? I get heckled by people about why am I reinventing this? Why am I doing it this way? There's already a solution. Why am I doing it that way? Why can't you just do it the way that it's supposed to be done? Why do you have to, you know, why, you know? And you and I are the same. Like, what is it that makes you need to look at something and go, I'm not happy with the solutions that are there?
Yeah.
Like, I need to reinvent this. Like, those solutions, they work. Clearly they work. They could be an industry standard, right? Or they could be a known working thing. But you still look at it and go, it's not like, I know for me, I don't look at it and go, I can do better. I'm never trying to do it better. But I look at it and go, I don't want it to be like that. I imagine something different for this. Right?
Yeah.
Which is what makes me do it. And you do the same thing. Why is that?
Yeah, I think the most honest answer is probably I'm not quite sure, but I can't resist it. But obviously the answer, which is that I think that knowledge and knowing the names of things is not necessarily the same thing. So if you want to learn how things work, and if you go read a book or just learn something from school, you learn this through the communication through language, right? But the knowledge on how it works and how it feels, that's I believe that's separate from just knowing how things work. And
Right.
if you kind of make stuff and see how things really work, you kind of get the knowledge of how things work, and you kind of like feel how it works, right? And then most times you just understand like, oh yeah, then I understand why it's solved in this way. And that's mostly how it ends up. But sometimes, which is enough, there's like, oh, hold up, there's something here that's like could be done different, or if it's done like this, it will unlock something else, right? So I think it's the excitement of that, and also just like to try to learn it on a different level.
Okay.
Right. So
the learning on a different level, like pulling something apart and learning how it works, and maybe improving it. Like, so Digital Thing just wrote, it works, but yes, I want to improve on it. All progress is incremental. But that's not what we do, or that's what I generally don't do. I don't look at something, take something that works and make it better. I look at something and go, I want to do that, but totally differently, right? I'm not looking at and improving someone else's thing.
Yeah.
So with my stencil printer, right? I'm not trying to. I don't want to make a stencil printer like from scratch. Like I don't have the time. I mean, okay, let me take back. I'd love to make a stencil printer from scratch. If I had the skills and the time and all the equipment that I could actually make my ideal stencil printer, I would love to do that as a project. But I have a immediate need for a working stencil printer right now because of my production. So I don't have time to do that. And so I'm left with how do I make what I've got work better, right?
Exactly. Yeah.
But generally, I try not to do that. I try to come up with from scratch. I'm not trying to improve someone else's design. So a classic example is Sam and my component rack, right?
Yeah.
My need for it to be wireless, and my need for it to be portable, and my need for it to be modular, right? Like these are requirements that I had. So that's how I designed it, even though there were existing things I could have bought, and there was existing physical connection technology that I could have used for them to communicate with, and all the things that I could have done, but I chose not to because I set myself some requirements, and then I built it. Now, I didn't set myself some requirements and then say, now can I find a product that matches that, right? And then can I get that product and maybe can I iterate on it to make it better?
Mm-hmm.
I said, this is my requirements, and I built it from scratch.
Yep.
And that's what you're doing as well. Like, you didn't take an existing stencil printer and then take it off its hinge and then add some extrusion to it. Like you built it from scratch. Like,
yeah.
Like started with nothing. Yeah.
Yeah, definitely. And well, when you start just trying to solve the task as it's not been solved before, you don't fall in the trap of looking at kind of the path dependency of something which is existing, right? So everything, like the comment said, that everything is incremental, and because everything is incremental, you will bring with you the missed opportunities, or you will miss out on the missed opportunities in the previous iterations, right? And maybe times have changed, maybe something is different now, that if you would track back all the iterations that has been done, maybe you would go in another direction earlier, but you didn't do that. And in order to kind of do that, it makes sense to just like start over, see it with fresh eyes. And sometimes you really appreciate the engineering more that's being gone into it, and you understand why things are the way they are.
Yep. Sure.
And yeah.
Okay. Yeah, it's okay. Sorry, I was thinking about something but got distracted with the chat. Sam just called us challenging, maybe just challenge. No. Oh, I'm challenging. I'll admit it. Right. So, like, I look at the stencil printing situation, and I look at the manual stencil printer that I've got, which you can buy, I don't know, 100 different versions of from China, right? And then, there are plenty of non-Chinese based companies that have similar products that they've iterated on. You got semi-automatic stencil printers that come in all different shapes and sizes, starting price of $10,000 or $8,000 plus, right? For a semi-automatic machine. You know, cheapest fully automatic Chinese machine you can buy is like $30-something thousand. And I look at all those things and I go, you know what? I've personally stenciled, I don't know, thousands of panels, right? With a manual stencil printer. And it's got one unique flaw, which is that it's impossible to get the stencil flat on the PCB. And compound that by I keep changing PCB thicknesses for my different products, and which means I have to keep adjusting the height, and the height control on all of them are terrible, right? And no one's managed to fix that. And I don't want to fix that because I don't know if it can be fixed. Like, I can't think of a way to make that any better, right? When you're talking about, 10 microns, 50, 100 microns difference in height. You can't do that with your hands and your eyes, right? So I was looking for, how do I make my life easier without having to spend $30,000?
Yeah, exactly.
Because the only way to make it easier, really, like even with the semi-automatic, you still got similar problems. You still have to manually align it, and you have to hope that the stencil comes down and sits flat, and you got to do that by eye. You know what I mean? And, it's not like every semi-automatic stencil printer comes with a built-in magnifying, microscope, right?
Yeah.
Go through and let you look right in to see how much you're touching it. Like, it doesn't. You got to use your eyes. So for me, it was about, how do I just improve my life? By, without having to strip down the machine, pull it apart, and reinvent it. And I think a few people were quite shocked, like, when I showed my stuff and you started showing your stuff, about how simple this solution really is, right?
Yeah, it is.
And even on my video, the last video I did, where you could clearly see I couldn't see, that just shows you, I could not even see with my eyes when I was recording the video how far off the stencil was at the front.
Exactly.
Like, it was, you could see when I did that close-up angle that it was not even close. There was at least 2 stencil thicknesses off the PCB. Yet I still got a really good paste out of it. One of the best plates I've ever had, except for that smudge bit, right? And like, people were just shocked about how much of a difference a vacuum cleaner in a 3D print made.
Yeah, it's crazy.
And these machines have been available for what? How long? 5 years, 8 years, I don't know, really long
forever.
time. Yet no one solved this. Right? And here's a vacuum cleaner.
That's what's, so the thing with when I started to think about, like, using vacuum, obviously I also been experimenting with a bunch of pick and place stuff as well. And this, it's like, so it's quite easy to when you have expensive machines, which is very both accurate and high precision, to lift these parts very fast, because you get like a really good contact between the nozzle and the part itself, and everything is completely flat or parallel to each other. So when you apply vacuum, it just works, right? But when you kind of build stuff at home, that thing is pretty that thing is pretty hard. Or if you look at like the cheaper machines, which has lower standards, this thing becomes like a problem. And I was thinking, like, this is like quite the opposite of like when I do vacuuming, right? Like if you vacuum clean your house and there's like a sock under your couch or something, there's like a guarantee that you will get that in your vacuum cleaner, right?
Right,
And it's like, there's like some derivation here between this vacuum thing. But once I ordered kind of my first small vacuum pump, I kind of understood. I was like, oh yeah, I get it. It's like it's so small.
Yeah, and noisy.
Yeah. But
small.
I'm gonna be really honest to say that the noise of like the small piston pump is enough for me to not even use it, like, because it's like hopeless. Anyway, the vacuum cleaner, it probably makes more noise, but it's like a different kind of noise. I'm not sure, but it did cost something to even suggest to use a vacuum cleaner, right? Because it's not like a proper way. And to me, it was also like, maybe I should make like a radial fan or something, 3D printed, or like an axial fan. It's like, yeah, I'll do that. I can use some motors and blah, blah, gonna be fun. And it's like, yeah, but what if I had like a gun to my head and I just needed to get this stuff done now? What would I do, right?
Right.
And
That's
it's like,
exactly it.
I'll just grab the vacuum cleaner and I'll just put it in there. And it's like, hang on. And then there was like, let's just try it, right? And I started to think like, okay, I can just drop the entire machine that I've built, like everything, if just this vacuum thing works.
Yep.
And that's pretty cool. Because I spent a lot of time trying to put this machine and these machines together. Obviously, you need to do some talking with yourself and like, okay, but if you just stop looking at that stuff as wasteful and it's like, yeah, you can use that knowledge for something else, then it's not going to be waste, and you might end up with something unique, which is very simple. And when everybody sees it, everyone is going to be like, obviously that's going to work.
Sure, right. It becomes, and then you look into other industries, and it's not new. I mean, you've got vacuum beds in woodworking, and you've got vacuum beds in metal working and stuff. I mean, that's been around forever. So someone I think it was Fred, just mentioned here that, like he had a one that for woodworking that connected to a vacuum cleaner that sucked. Okay, like I'd never seen a vacuum cleaner used in that situation before, but I'm not in that space, right? Maybe that's been around for a long while. I don't know, but like, as you know, I was coming from the like, how do I put a vacuum bed in a CNC? How do I retrofit one in a CNC? So for those that aren't aware, when I started looking at this, I wanted to see if I could put my panels into a CNC and cut my panels apart. I cut my boards out of my panels. How would I hold the panel in place? I can't clamp it. I can't screw the panel onto a board. I would need some form of vacuum to hold it still. And you look at all the desktop CNCs that you can buy, open or closed, and none of them have support for a vacuum bed. You have to make something custom, right? So that's why I started looking at a vacuum bed, and I started looking at vacuum pumps and Venturi and all other things, and none of them give you the level of vacuum that you really need, or if they do, they're really slow. Like a vacuum pump, produces vacuum pressure over time. I need it's on, it's off, right? I need to grab it, let go of it, right? Excuse me. So, and that's when both of our ideas kind of collided.
Yeah.
Right.
Yeah.
Totally opposite things, but I mean, I don't, like, I know you didn't, and I didn't go to other industries and go, how did they solve it? Right. I wasn't looking for inspiration anywhere other than there must be a solution here. Like, I did look for anything to do with vacuum beds and CNC, and there's virtually nothing out there. Right. Yep. It was just it was a real aha moment.
Yeah, and I spent a lot of time. So I listen to a lot of books. I'm going to say listening to books, because if I say read, it probably means I'm actually looking at the books, but I'm not. I'm just listening to audiobooks, and I've been reading a lot of history around technology and all this stuff, and in our society where we live today, we become so expertise driven and have proper ways of doing things, and engineering have solution for most of the stuff that's in a way or another.
Yep.
And like the first cyclotron was made by like washing machine parts, right? And this cyclotron, you know what that is?
I know it is. I just know it was right.
So it's like the pre-machine for the particle accelerators, right?
Yeah, I didn't know it was washing machine parts. That's interesting.
Yeah. It was actually built by it was not built by the professor who kind of came up with the design. It was built by his assistants, right? It makes you also think that maybe this professor actually just took the credit. I'm not sure. That's just speculation, but you never know, right? Sure. And you really don't see stuff like that anymore, right? Now everything is just like polished startups. Like you don't go and launch a startup, get money from venture capital by showing stuff which is made of washing machine parts anymore. But
no.
So
the climate's definitely changed, but it depends. When you're going for startup funds, that your aim is different. When you're going for startup funds, your aim is to build something that you can sell and make a lot of money and exit, right? Which is different to
exactly.
I want to invent something to change the world.
Yeah, exactly. And startups are mostly financial assets, like they're investment vehicles. That's what people kind of need to understand, right? Especially if you're funded by VCs, right? Yep. And everything, the way, and I've been, into that game as well, and it's something completely different than like you say, that's why I really like this stuff that you're doing, just making things works from home, and just see the possibilities. So you've been obviously like a huge inspiration to me and probably hundreds or thousands of other people. You're just like grinding at home, just making it work with what you have. And it's like, suddenly you're like, I shipped like 5,000 tiny picos today. It's like, you did what? It's like,
sure.
Yeah. So, and it just proves that it is actually possible to kind of go do this thing without, launching a startup with investors and all this stuff, right? So that also means that everyone has this opportunity to go do this stuff. And I think like you have probably inspired and also taught and learned a way how to do this stuff for many people that probably have already done this, right?
People I hope
trying
so.
to
The difference is my aim was not to do this when I started, right? Like I kind of fell into where I am right now. My aim and motivation wasn't that at the start, which I think is the difference. Like if I would have started from day one with I'm going to build a hardware company, right? I'm going to start a YouTube channel to help me build a hardware company. I would have failed, I reckon, most likely.
Because then you need to fit into certain standards on how that should be done, right? Like, and you would have advisors that said, you need to go to like a CI or you need to do it like this, and this is the time you're going to spend on this. This is the marketing, and all this stuff, right?
Sure.
So,
but like, there definitely are people out there I know that have, like I've followed in plenty of people's footsteps. Like I'm so far at the end of the line of people that have done similar, right? So and then there are plenty of people behind me who are doing similar. You know what I mean? It's just I think everyone is just learns and is motivated by other people. That it is possible to do this type of stuff, but it's still like all my boards and everything I'm doing and I'm selling is still very mainstream compared to the alternate thinking stuff, right? The left field. I guess I'm more interested in the left field stuff. Like, so, as I was saying to you yesterday, like I'm really motivated again now to go back to my my auto parts picker. Like I've got my manual turntable, right? But that manual turntable came from a need for me to build my boards by hand faster, which I no longer have that requirement, right?
Yeah.
But there's so many people out there that do. Like,
exactly.
As I say all the time, the hardest part about assembling from hand is getting the components out.
Exactly.
not the placing of them. It's not knowing where to place them, because there's plenty of tools that help you with that. It's the getting the actual parts out. That's where the time's wasted. And
exactly.
Right. And so you've immediately gone in a completely different direction to me for this problem, right?
Yeah.
Then and that's what I find fascinating, right? So I guess this is letting everyone know the cat out of the bag, whether you do or don't end up working on it, right? But like what we've been discussing, so Marius has got a completely different concept and idea of how to solve the parts problem of getting your parts out to build a board by hand than I've got. And both of them could be absolutely awesome.
Yeah.
But so different.
Yeah.
Yet the industry generally standardizes on one way.
Yeah.
Right. Which is what I find frustrating. Like something gets done and used, and you might see variation. Different people make different product versions of that variation, but they're all kind of based on the same thing. Yeah.
Mm-hmm. Yeah.
Like my manual parts picker. There's a few other versions out there you can download on Thingiverse, and the can't remember his name, the guy that's done the version now that's connected to the computer that as you spin it around, it indexes and it shows you what the part is on the screen. And there are people who are taking this idea and running with it, which is awesome, right?
Yeah.
But there are so many other ways to do this.
Yeah. And I think and this has kind of been also like some way of a light coming up for me as well. It's like just do it the way that you do it. If you assemble it by hand, you could basically, and this is probably something I'm probably going to do on my channel, like just assemble boards by hand and just time everything. It's like what takes the most time. Like I would bet that so when you have a lot of components in bags, right? Even though if you have the best system, it's still going to take a lot of time to get all the parts out, right?
Yep.
And then you have to unbag them, untape them, and if you have the wrong reels, like the one you have with paper, right?
Yeah.
So getting just something out of a paper, so you need to use like protective glasses, right? So even that's just like a problem. Right. So I'm obviously I started as well to just go kind of down the same route, just like, okay, I'll just build a pick and place machine, which is smaller and slower and all that, and I thought it's like, okay, I'm not going to use automatic reels and stuff like that. I'll just pop out the components that it needs, and it's going to just pick up everything based on vision and just place the parts. And then I thought more about the stuff that we have been talking about.
Yep.
And we talked about it like a couple of days ago. Like the picking and placing part is actually not the thing which actually takes time. It's like human dexterity is not that bad, and it can be done pretty fast. Yep. And it's not going to help you that much to do that part. So maybe the smartest thing you could do is just have a fast way of getting out the different components you have.
Yeah. Let's face it, most people that are most people that are assembling boards at home, right? And let's focus at home. They're not making hundreds of boards. Like they're not doing a production run. If they're doing a production run, sure, you go and look at some form of pick and place machine or something, because you want to be able to do the automated things you want to remove from the person and let the machine do it. I get that. But most people that want to sit there, I just want to build one board, or I want to build two boards, or I've got 3 different prototypes I'm playing with. I want to assemble them all together. They don't need a pick and place machine to do that. Like the amount of time to set up the pick and place machine to build one board, you could build it by hand much faster, right?
Exactly.
Yeah.
So I bet so. If in the time I would build one board, if I had 50% more time, I can probably build 5. And by the time, if I had twice the time, I could probably build 10. And if I just pop up enough parts that I could just move them around, and you get this nice technique that you can pivot them around with your it's not called pliers.
Turntable. Yep.
Yeah. So, and then if you're going to do this with more expensive stuff than just passives, like you're adding like a microcontroller, and especially like if you're using microcontroller these days, it's gonna be worth to try to get that stuff like really good, because if you mess it up, it's gonna be expensive to fix, right? And also, if you're going to make more, how should I say, advanced and expensive products where you use kind of more expensive sensors, it's just gonna be very risky to do all that with a pick and place machine.
Sure. So Aaron wants to know.
I missed that comment. What was it? So can we approach? Can we describe the approach of first idea for parts?
Are you willing to explain your approach to how you're going to deal with this? Because like my approach is, I'm still going to go for my turntable, but my turntable is going to be an automatic one where it presents the next part to me. So if I'm building a board, it knows my BOM, and it's going to automatically rotate to the part. So I just keep grabbing parts from one spot and I place them, and then it rotates and gives me the next part. I don't have to go and find it. I don't have to go and look up what it is. Like, you know what I mean? It presents it to me.
Yeah.
That's very different to yours. Do you want? Is it too early to talk about yours? Or
no. So the way I've done it on the machine that I'm in is that I have like a big LED panel, and it will basically say get part number C107452, put it on the red field, and then you just place it on the red field, and it will go pick it up, and it will place it where it should be placed. You can put the PCB in any direction you want, because like you just do offsetting on the fly. Yep. But the thing is that even though this leaves out the biggest problem, right, which is finding the right parts, right?
Yeah.
So even though it tells you what part to it's only going to replace the placing of the part. So I really think so. If I were to, I kind of landed on like, okay, I think I should make like some rotational device thing as well. I've obviously been inspired by your rotating thing, and it's a cassette like this could it can hold thousands of parts, right?
Yeah.
And should be pretty simple to make. And I had some ideas that you could build the stepper motors into the PCB. Maybe you can make it has like a PCB bottom, and then have it automatically spin around and do the thing, find the right parts and stuff like that. But I'm also, because I've worked a lot of with the motor drivers, and like in general for making purposes, I would really like to have like a core, not a Core X5, but like a gantry based machine, like something that looks like a 3D printer, but I can put whatever I want on it.
So you're talking about a generic,
like a generic machine, right? So even so, I can attach a drill to it. If I'm going to create like a huge aluminium plate that I'm going to drill 40 holes in it, that's really easy to do in Fusion, and you can just like pre-drill holes for it, and you can just drill the big holes with like a big machine, and it would be like really handy to just do that. Or to do, you can do other pick and place tasks as well, like sorting your stuff, right? So and I really like, I need this machine myself, and I think it will be very helpful. So I was thinking, okay, it's probably easier to make everything if I have this machine. So I'm going to build this machine, which is just basically going to be like a CNC machine, and like looks like a CNC. What is it called? I'm really bad with names of stuff. like a gantry-based machine with a moving y-axis. Yeah. So, and I would like to have that to do picking and placing for me. However, that machine could easily be picking parts from a rotating cassette, right?
Yep.
Because that's more about how you store the things and the parts, right?
Yep.
And it's like I run into kind of my own thinking of just trying to engineer something the way it's supposed to be done, right? By not thinking of the steps of just locating the different parts, right? Setting up like a professional pick and place machine takes like ages, right?
Yep.
Like that's so when you have a machine that can place 100,000 parts in an hour, just think about what the downtime of that machine costs, right? It's like insane. So
Sure.
yeah, and you also obviously had a bunch of problems with your feeder cassette as well, like in the past. So
yep.
it's probably something not worth like at this stage, right? Because right now I really want to focus on just making it possible for more people to make electronics, right? And I think it should be. So I'm thinking like, okay, so I really can't resist myself trying to help out with this cassette thing that you're working on as well, but I'm still also going to make like the CNC and that stuff.
Okay, so explain to people how that machine is going to solve the parts thing, right?
Yeah.
Forget about the pick and placing. So let's pretend it doesn't do pick and placing. You're manually assembling, right? So how does that solve the getting all the parts out thing?
You think about getting out of the tapes and that stuff, or just like, yeah. So you think about like I told you about the pill box and all of that stuff.
Right. Yeah, but you haven't told everyone else. So
yeah. Okay.
So that's insane. Yeah.
Yeah. So if if people would imagine, this probably has like a proper English name, but let's call it like a pill box, which has like Monday, Tuesday, Wednesday, blah blah blah, right?
I think everyone knows those components.
Yeah, different compartments, right?
Yeah. So 100 different little boxes with the lids or no lids, whatever. Yeah.
Yeah. So if you had had something like this made up out of a PCB, which would be the bottom of this, and then you could create a separate PCB which has kind of the cutouts, so it would mill out the compartments, so to speak. Right. And you can put many of these together, and it's going to form like a compartment that starts to look like a pillbox.
Yep.
And at the underside, maybe you can even put some RGB lights, so you can control what should be placed where. And you don't have to have that big of a compartment to store hundreds or even thousands of small passive components. Sure. So I bet that for like a cassette which is like 30 by 30 centimeters, it will probably hold most of the small parts to make like almost any, at least of the maker products, right?
Yep.
So even because these things are really small, and it seems to be pretty safe even to store it like that.
Yeah.
Especially when you're making things for yourself, right? If you're making things for production, right? You're probably not going to take that risk. But if you're just going to, it doesn't matter if you break like 10% of the parts of at least of the passives, right? But this would be like a big problem if you're like a professional manufacturer. So
Bellini's got a patent pending. I use a projector to highlight all the pads of the component I need to place. Sure.
Oh yeah.
You're still going to get the component out though, Bitluni. That's the thing we're trying to tackle right now. Not where do I place it, but
yeah,
where do I get it from? Yeah. Okay. Yeah. So how do you get the components out of your little things? That's the key, right?
Yeah. So I would definitely start with the vacuum cleaner again, and just make a controllable, a vacuum, a special vacuum cleaner head for picking parts.
Right.
And just start with that. Because I know that,
Right,
that
so
could
you're
be...
thinking about your gantry moving across the storage containers, going to the part it needs to get, picking a part, and rather than placing it on the board, it's going to present that part to you.
Yeah, you can do that.
And then you place it on the board, right? That's what
you can do that as well, right? It's obviously not that big of a task if you can, if you have like a upwards facing camera to do the right offset, right? Because if you're going to pick up a part with a bigger nozzle, it's going to need some serious offsetting, right? Compared to picking it up with like a really small jukey nozzle, right?
Sure.
So, but if you can offset it through a bottom camera, it's quite easy to place it as well, just based on computer vision. Yeah, obviously, it's going to take a lot of time compared to professional machines, but
So Aaron's written, I need one 0402 part, but the Dyson part picker gives me the entire inventory on my desk because it's like
but that's a fun part of it, right? So here's the thing: it's like you could stick the vacuum cleaner pickup nozzle in the compartment, and it will pick up whatever is the size of the hole, right?
Yeah.
So if you can fit 2 components on the hole, if you're really unlucky, you pick up 2 at the same time. But you will see that on the vacuum camera, right? And you can just have it, bring it over to a special place on the machine. You can just drop it and just pick it up again, right? It doesn't need to be harder than that. Then you'll just, now I have one. And if you were,
I think what people are missing in this, right? And it's fair enough. Like it's a complex system. So Marius' idea is that on top of they're not open trays, right? With the parts sitting, they're closed with an aperture. So if it's 0402 components, there's an 0402 sized aperture at the top. So the vacuum goes on top, the vacuum nozzle, whatever it goes on top. And it's technically, if a part gets sucked into it, then it's going to block the vacuum on it. And it's only got the one part because there's only an aperture for the size of that part.
Yeah, exactly.
That's what you're talking about.
Yeah.
Right.
Yeah. So it could pick up, one or maybe more, but it doesn't matter that much because the good thing about making the worst pick and place machine is that you have time, right? So if you have full control over the software, because obviously, like I said, these motor drivers are going to be controlled from Python, right? So I can just present it from a camera, drop into the ground. It's like even to get parts orientation right, you could do the same. It's like, oh, I didn't get it right. So it's like, how do you flip parts yourself, right? When you hand assemble it, at least I kind of just like flip it, drop it. It's like, oh, maybe sometimes I have to do it 5 times.
Sometimes I pick it up and drop it. Sometimes I hit the corner of it and it flips and it goes back on its back again and I flip it. Like sometimes I have to try to flip a part 10 times before I get it the right way around.
Yeah, and the machine can do this, right? Yeah, a machine can do this as well. But it would be the absolute worst pick and place machine in terms of for the industry, right? Because there everything is measured in time. But it doesn't matter and that's also it's like one of the reasons why I think you would benefit from just starting from scratch on everything and just trying to solve it, because you're solving it for a completely different, it's like going back in time and trying to figure out how this is supposed to be done, but you have all the tools of the modern world, right?
Sure.
So
okay, so this is as I said at the start, you and I are very like-minded, right? And I get like I'm reading the chat and people are coming up with all of these, but what's if this happens? What's if this happens? What's if this happens? What's if this happens, right? And so the point with this and this way of thinking is that neither of us, right, we don't worry about all those things. Like that's something to solve when we get there. Like, so with modern day design, like, and I'm generalizing here because I'm no expert on anything, right? But in modern day design, let's say someone is building a product, Let's say they're building, let's go simple. Let's say they're building these calipers, right? they have worked out all the nuances of everything to do with this product, how it's going to work, how this is going to happen, where you change your battery, where this is going to be. I need all these parts to be this size. I need this many screws. These are the holes. This is the molds I need. Yeah. Everything they need before they go into production. Yeah. They might prototype it a bit, but they have everything mapped out, where you and I, we don't do that. You and I say, I'm going to design this machine that does this crazy thing, and I have no idea how it's going to work. No idea.
Yeah.
How's it going to solve all these problems? I don't know. So let's get started. And we start doing it. And we work it out as we go.
Yeah. And, many times these obvious things happen, right? Most times it does, right?
Yep.
And then everyone can be happy and say, like, yeah, I told you so.
Told you so.
But sometimes, it doesn't happen.
Right.
And if you just like this, I even shocked myself with this like stencil printing thing, right? With this plastic box with the springs and everything. I was like, oh, it's going to jam. It's definitely going to twist a bit, and just like nothing of that happened.
Right.
So the hard part of making this stencil box thing was giving yourself permission to actually build something that stupid. But once you do that once, you kind of learn that maybe you shouldn't think that much about everything that can go wrong. Yeah.
Right. Because what you end up doing is you end up solving the problems that may happen, but may not, and wasting time doing that.
Yeah.
Rather than finding out what needs to be solved.
Yeah.
Right. It's the
Yeah, but if you look at something a lot bigger projects, if you go look at SpaceX and how they're started to build Starship, right? It's like they're like compared to building, the space shuttle. Like the space shuttle, it's like an utter disaster. It's like a very nice piece of engineering, but it's like a cost nightmare. It didn't work the way it's supposed to work, and then here you have suddenly water tower welders building rockets in Texas without the clean room, without, obviously they have clean room for parts, but not for, like, this would like never happen within the industry. Exactly. Yeah. Right. Yep. And they just throw away the rockets. Some of them that not even are going to fly. And then, it's basically, it seems to work. Seems to have a really good and fast progress.
Right. I mean, they have a ship that they're building that has certain type of fins and stuff, and they haven't even flown it yet, but they've already got 3 other versions they're making with variations of those fins.
Mm-hmm.
Not to solve the issues on the fins on the first one, which they don't know is an issue yet because they haven't flown it.
Yeah.
But because they don't know what's going to happen, so they're trying different things to see what works best. I mean, obviously, it's really extreme the way they're doing it, and costly and stuff. And yes, as Simon says, they've got huge budgets, but they're not doing the whole, let's try this and see if it works. No, okay, let's tweak it. Let's try it, see if it works. No, let's tweak it, because that's really slow. Right? Yeah. So they're going and saying, well, here's a whole bunch of different things. It's like, I'm going to throw a whole lot of things at the wall and see what sticks. Right?
Yeah. I think, I think like, so humans really like to predict things and feel very safe if they feel that they have someone who can predict how things are going to work. And especially within the corporate environment or in a professional setting, you don't want to have a suggestion that will fail, right? Sure. And because of that, you are going to mostly use things that you know how to do. And also, if you look at like this when it comes to circuit boards, right, which has like extremely high risk when you do really high volumes, right? So you're going to make like 20,000 of a board. Of course you can spend 200 grand on a PCB simulation software, right? But it kind of has its defect in trying to predict things, if it was going to work or not. And I think it's part of because we professionalized everything, and also everything has become very expert driven or like siloed up in, you educate yourself to become something like part of a group, like an engineer or or even like a subclass of a specific kind of engineer, and you do things like this, and you're not supposed to go and do other things, right?
Yeah, stay out of, stay in your lane and don't go into my lane. Like, do what you're employed to do and whatever. Right. So that's all about risk mitigation, right? It's all about appeasing investors and the the board of directors and making sure that you reach your budget targets and you don't overspend, you know what I mean? And you get something in the end that can be profitable for the company, and you know what I mean? All the motivations behind all of that has nothing to do with invention.
No, exactly. Yeah, so like one of the reasons why I think Elon Musk is so successful is that he got permission to just do stupid stuff, right? So if you're like the CEO of ULA, right, and then you started to suggest that you're going to do something of like the reusable rocket and this stuff, everyone is like, probably not. But Musk has this habit, or at least now, to make like crazy predictions. And then sometimes it works, but
Sure.
because if Elon Musk would suddenly start to be very like professional, that would set people off, and that would be like, wait a minute, what's happening now, right? That would be bad for him. So he is just in a specific position where he is able to do all this stuff, right? So he is pretty smart, but a lot of the stuff that they're doing is like very obvious stuff, right?
Was
but
obvious in hindsight.
yeah, but I bet it is obvious for many people as well. But it's just like no one dares to actually try it because no one will be given the permission to try it, right?
Well, because the motivations are different, right?
Yeah.
Like again, we're going to be careful talking about Musk, right? This is not a pro or negative thing like for Musk, but his motivations are not driven by the same ones that a normal corporation would be, right? A normal, company that makes rockets or company that makes aeroplanes or whatever, their motivations are always driven by their bottom line, where Musk's motivations are, I need this thing to be able to do this thing, to be able to do this thing to hit my end goal, whether you believe it's possible or not, right? And shrinking that down, because that's really big stuff. Like shrinking that down, that doesn't even happen with small companies these days, right? Because small companies, the 100 employee size companies, you quickly get into the situation where, well, you've got employees to pay and you've got, your medical to pay and need to make sure that my employees stay in their jobs, and I've got customers to satisfy. And all of a sudden you become very risk averse.
Yeah.
And when you got something that kind of works, you then just keep doing that one thing, or you know what I mean? And you improve your profits or whatever else. Where the whole makerspace is anti that. Like the whole makerspace is about, what can I invent? What can I make? How can I do things differently?
Yeah. I think that like one reason is that it seems like most people do this in their spare time, right? So, and obviously there's going to be a lot of products which is made just for the fun of it, or for like the intellectual stimuli of just solving something which you find interesting, right? Which is like really great. But I think what I really hope that is going to happen also is that you will start to have, how should I say, like building blocks that can also be more beneficial for a wider audience, so to speak, right?
Yeah. Well, I'm really keen to see if you can pull off your machine, if you can, if it can do what you're talking about, and I'm sure you'll give it a red hot go. And you've got your new YouTube channel now, which you're going to. You mentioned yesterday to me that you're going to like possibly stream a lot on it to kind of show people what you're doing, maybe, or just make videos about it.
Yeah, so I think I was trying to look at, if you look at people who live off content creation, which is mainly gaming streamers, and like crazy people doing all kinds of stuff, right? Which is kind of hard to relate to. But like gaming streamers are basically, they're sitting in a software program, which happens to be a game all day, and they produce a lot of content. And I find myself diving into, even if it's like a PCB design program, or if it's Fusion, anything, it's not going to be interesting for like a very wide audience, but there still is an audience for this kind of content. So I'm going to try to experiment with just streaming more, general stuff, and then I'll try to make like highlights maybe of that and put that on like the main channel. It's like this is like also like learning also from like Bitlooney's trash channel, which is like a total gem.
Right. Okay, hang on. Aaron wants to. It's in the description for the stream. Aaron, he asked about sharing the channel, but let me just I'll grab the link again for your channel and post it in the chat for everyone. Or what I'll do, I'll post your last video. That will let people.
Yeah, I'm gonna go and look at all people's comments afterwards, because I haven't looked at any comments yet, because I probably wouldn't be able to focus, just like read comments. But I'm really interested in figure like all of the things which people say that could be problems, because obviously I really enjoy that people say that things is not going to work. It's not necessarily because I want to do like I told you so, but it's just like interesting. Like sometimes obviously there is something that you miss, right? Which could save you a lot of time, or it could give you an idea. Even if you misunderstand something someone is saying, that a good idea can come from that as well.
Yeah, for sure. And like, I've got the list of not stupid, I shouldn't say the word stupid, the list of silly and failed ideas from me is massive. Like, you know what I mean? Like, just, I've had some success in doing things my way, and I've had plenty of fails in doing things my way. Right. And some of those things, someone could have said to me, that's not going to work for this reason. And, I could have maybe got there earlier with it doesn't work, rather than get to the end and come to the same conclusion. But there's so much learning in between. And so I will often, I don't do it to spite them, but I will often push through anyway, even if I fail, and come to the conclusion that, that allowed people to say, I told you so, just to get the learning, just to get the understanding. Like, obviously I don't want to invest 6 months on something to get to that end point when I could have avoided that. You know what I mean? But
but sometimes I do that.
Sometimes, right? Yeah. And sometimes things are just never finished, right?
Yeah. But there's like the concept that I learned, or starting to understand probably as I get older, is that this might be just limited by the way humans talk to each other, but it's like the concept of something being true or not true, right? Or like humans like to say like, oh, this is a good idea, this is a bad idea. Like this person is bad, this person is good. He does this thing because of this reason. No, it's not that reason. And everything is just like Boolean logic. But if you just look a bit deeper, you can understand that it's never like this. And I think that at least for me, trying to just look at statements like this as there were floats or something like a numeric value, right? So if someone would say like, okay, so making this machine is like a really bad idea because of X reason, right? Instead of thinking that as like, okay, is that true or is it not true? I would think it's like, okay, maybe it's like, let's say there's 10% true, right? But is that going to be enough to tip me over from not doing it? Maybe if I get like 10 of the 10%, right?
Yeah.
And just like things can be good and bad at the same time. Most things are both true and false at the same time. And just like looking at this from this perspective really helps in, thinking of things and make it easier for you.
Sure. Absolutely. I I generally don't look at things as percentages like that. I generally don't. I tend to just ignore the fact, like it's going to fail or it's not going to fail. You know what I mean? Like until I've come to that conclusion, I just ignore it. There's a thing, right? Unless it's a really like, hey, I'm gonna make this pen fly, right?
Yeah.
If someone says that's not possible, and okay, well that one I'll go, yeah, okay, it's probably not possible. But but if there's a chance that it could be possible, I ignore. I don't weigh up a percentage to decide, right? I try to take it to as I can.
Yeah. I don't mean that you necessarily don't need to put like a number to it, but just like think in that sort of way instead of thinking of things to be true or not, right? Even if you look at like in a data sheet, like there's always a number for where an analog voltage signal is true or not, right? And it's a specific voltage for where it's like a low, right?
Right, plus or minus.
Yeah, exactly, right. So this is how, like,
pure science. Even pure science has a gray area, right? Yeah.
Well, everything is, right? This is like the problem for physicists, right? It's like, oh yeah, you have the atoms, and then you start to look at things at quantum level, and then suddenly it's like, wait, it's not supposed to be like this, right? It's not supposed to be just like observations and predictions, and this is not how things should work, right? And then when you talk about things being in superposition, where you basically have something to be true and false at the same time, it's like, how is that even possible as a human to think of that? But when you really think about it, it's like, how can things not be like that? Everything has to do with like the observer's position on everything, right? It's like, is something bad for you? Is something good for you? You don't know. It depends on when you ask that question, right? So was this failure good for you, right? Was you could pull this to pretty extreme things, like should you have gone through some trauma, right? Maybe many people think it's like, oh yeah, once that happened, you learned something from it, and it was good, but it was also bad because I didn't like it to happen.
Yeah. I was going to quickly point out, sorry, I just need to highlight Mark's comment that he tried failure, but he wasn't good at it. Just that is so typical Mark.
Yeah. It sucks. It always sucks.
Yeah.
And it is the thing. It's like, it's when people say that failure is good, and it's like, failure is always not good. That's just like, let's just be honest. But it doesn't mean that you should stop, right?
Sure.
So it's like there's so much great stuff coming out of being uncomfortable, right? And not feeling good, right? And but I think it might be also like you can have a personality trait where you kind of you're not necessarily sadistic, but like you're kind of you're more known to things not going in the right way, right? Kind of living that way.
Yeah. So an interesting thing about me on that is that, like, I have no problems failing. Like, I'll keep trying, fail. Sometimes I'll give up, as in I'll say, okay, I can't do anything else, I'll put it aside. Sometimes I'll go, I'm going to take a break from this, put it aside, and come back to it later. But I also am I can't do sales. Like, I know this sounds stupid, but like, if I was a door-to-door salesperson, like, knock on the door, hi, I'd like to sell you a vacuum cleaner. Bang, shut the door, go there. Or someone on the telephone, hi, I want to sell you something. Hang up. Okay. Hi, I want to tell you. You know what I mean? I can't do that. I've tried a couple of times in my previous lives, like, to be that type of person. I can't do that. I can't put myself out there to fail like that. Right?
Yeah.
Yet, in the maker space, I'm quite happy to not only continually fail and push and try, but I'm prepared to invest my time and my money, right, into those potential failures. And I
Yeah.
find that quite bizarre about myself. And you know what I mean? And I think
Yeah.
one
Yeah.
of them is about skill, whether learning and acquiring, and the other one is about looking or feeling bad about yourself.
Mm-hmm.
I never feel bad about myself if I make something and it doesn't work.
Yeah.
Right? I try to work out why it doesn't work, see if I can fix it, improve it, or whatever. But I never think to myself, my God, you're a failure. Yet out there, I would instantly go, wow, I can't do that. I don't want to feel like I'm, you know, I can't have people shut the door in my face. You know what I mean? It's a
Yeah, but I guess that people have a different inclination in terms of how much like limbic resistance you have in order to do task, right? Like, and by limbic resistant, I mean like, how much does it cost you, right? You could be a door salesman if someone had like a gun to your head, right? You could probably do that, but you would be fed by adrenaline, right?
yeah,
Which is it's like one of the reasons why people do things at the last minute, right? Because they get higher adrenaline once the deadline is closing, and that helps with the motivation of doing it. But then there are other tasks which you don't need that much adrenaline or a motivation to do it, which and that is probably something that you should be doing more of, like, because it's going to cost you less effort to do it, right? So for me, obviously, it's the same. Like with I probably you and I is pretty similar in terms of like doing accounting and stuff, right? It's like it has like
I employ someone to do my bookkeeping work. I don't do
yeah.
any of my bookkeeping work.
It's like it has like a really high cost of doing it, right?
Yeah.
In terms of, how should I say, like how much resistance it's in me to just like go and do it. So, but it's
sorry. Right. Hey, I could be a horse if I was motivated enough to do it. I'm pretty sure
yeah,
you could
that's for
be a
sure.
horse. But don't let me tell you that you can't do it. If you want to
Yeah,
be a horse,
I'm getting pictures.
just stick around so I can tell you I told you so.
Yeah.
Oh my God. That is
Yeah,
hilarious.
I think there are humans on the internet that have been horses.
Yeah. So it's funny, like when you're talking before about putting a percentage on, someone says to you that can't be done, that'll fail, and you put a percentage on it. It reminds me of the film The Princess Bride, where they say, is he dead? Oh, he's only a little bit dead.
Yeah.
He's not dead, he's a little bit dead.
Yeah, it depends on how you see it, right? It's like, is he dead? For how long? Has he been cool? Like, has he been done for 24 hours, but he's been submerged in like ice water? No, you might, there have been people that have been in ice water for like, I think like a day or something and still be woken up, right? But
Have been? I don't know. You sure you haven't been watching Netflix?
Yeah. Oh, no, it's true. Yeah.
I don't know. Digital says, don't do the books, do the boards. More time to do the boards. No, I don't do the books because I have no interest, and I think accounting is just archaic and stupid. And
no.
Yeah.
Let me share something which I find very interesting, is that because I'm listening to audiobooks, I've this is going to be a tangent on the comment, because I just read like, oh, books, like it's like I don't read books, right? Because there's a lot less time to read books rather than just to listen it, right? And if you listen to something, you can just do other things as well. And then people ask me questions like, but maybe sometimes you can't follow what the book says, right? And then it's like, oh, that's fine, because it's probably not that interesting, and it's probably not worth remembering. And if it's worth remembering, you would notice. But sometimes you just zone out. But you just listen to books in a way you're not supposed to do, right? When you buy a book, you're supposed to read it. You're supposed to don't stop. That's a bad thing.
Yeah.
But you should consume books and this kind of stuff like it's junk food. Like, you just like, oh, didn't like that, just throw it away, continue. And you don't even need to remember like all the names and all the stuff which are in the books. You just need to kind of like because when you listen to it, you kind of go through the experience and thinking about what happens, and this will kind of reprogram your brain. You don't need to remember, what year the Napoleonic War started in order to remember why the reasons it started, right? So you can acquire a lot of knowledge like this and kind of reshape your brain without you even being aware of it, just by listening to stuff.
Yeah, I do a lot of reading. Like I read physical or digital now books. Like I do way more reading than I do listening to books, because I tend to zone out because my mind's going so fast that I'm thinking about something and suddenly I realize I just missed half an hour of what I was listening to. But ultimately, I don't know if I missed it because I might have grabbed stuff subconsciously. I don't know. It depends on what it is, right? That's about repetition and stuff. But so like Digital Things just wrote audiobooks is subconscious book reading. I don't do enough of that. I have to admit. I tend to listen to music more when I'm working. Because if I'm interested in the topic that I'm listening to, I want to listen to it. But I need to have to stop what I'm doing to listen to it.
It takes some time to get used to it. But what I did that helps a lot is that I speed up the audio, so it's a lot faster. Right. So I listen to like 2.5 speed, right? And for some reason, it's easier for me to listen to because my brain kind of goes fast. I obviously have like a ADD diagnosis, which makes this kind of natural, go figure. But it still sticks. And if there's, sometimes I'm just tired and I can't listen to it, then I might stop. But I usually listen to the books I like many times. Like some of my favorite books, I think like my favorite book is like The Way Technology Works. Is I probably read it like 20 times.
Right.
I
generally read. When I'm talking about reading, I'm talking about like escapism reading. Like at night in bed, like I'll read for a couple of hours before I go to sleep. Like I read a lot of fantasy, sci-fi type stuff.
Yeah.
When it comes to not other things like learning type reading, that's different. I can't read from the book. Like I can't. I won't even begin like all the different like electronics type books I've got on my shelf, yet I'd never ever open them, or I can't read them. I can't sit and concentrate for long enough, but I will listen to podcasts in the background and stuff while I'm working.
Exactly. Yeah, it's the same.
Yeah, it's the same thing, right? Yeah. So I guess, I see your point.
Yeah, I guess that you're fueled a bit with adrenaline as well when you're reading fantasy novels, like because something is happening and because things is not real, you can have situations that create excitement a lot of time. And probably your books have gone through like a long funnel of optimizing in terms of like being exciting, right?
Absolutely. But I how MOSFETs work. Yeah, absolutely.
Yeah. But I mostly read like I only read like stuff that you probably can learn from. But I also read a lot of history. But I tend to just get depressed by reading history.
Right. So Mark listens to my streams in the background.
Yeah, so I've done that as well. Yeah.
But he takes none of it in though. That's the point. None of it. Yeah. It's not like I'm showing something, but he's listening in the background, so he doesn't get to see it. Shame.
Yeah. This is it's quite an interesting point. It's like first time I talked with you in real life, I've been listening to your stream, right? So it was like. It was a very small step starting to talk to you compared to, to someone which was completely new, right?
Yeah.
And yeah, exactly. So, and I find this like I had this conversation with someone I know on a party. It's never a good idea to bring up this kind of stuff, and I was like. I think like this podcast and the stuff we're listening to is some kind of like replacing our social relationship, right? So it's like, I bet that like your brain doesn't really see the difference between Sion talking to you in one way and like some other friend, right? So you kind of have like this virtual friend relationship with all your listeners, right? And I think that's pretty interesting as well. It's like because and I also end up listening to a lot of stuff from similar people, so I kind of get like this group identity around this stuff. And I said in this party, I was like, but like and it was like it was a female, and she was like listening to like a podcast by like one of the most popular podcasts here. And I was like, yeah, have you ever thought about that? That show might be like a replacement, of Friends, because these people are really funny. It will obviously be someone who everyone would like to have as friends.
Yeah.
And I think like a lot of this stuff that we're doing online like this is this thing. And I'm not saying it's a bad thing. I'm saying it's good, right? Because when we are,
it's good until we start stalking them, right?
Yeah. But it's like in real life, we are constant. We are, limited by our geographical location and not necessarily our common ideas and what we find interesting, right?
Sure.
But what's happening all over the world is that we're kind of creating all these like-minded communities, which is not limited by geography. And we kind of have friendships even like with each other. And if you look at all of the biggest podcasters, like with Joe Rogan and like Lex Friedman, and these people tend to have like this like personality which seems to be like the ideal friend, right? Like there's probably a lot of people who would like to have a friend like Joe Rogan, which is like cool and macho but also smart. He just like smokes weed, doesn't give a damn. And then you have like Lex Friedman, which is like the intellectual smart guy, but he still has like both feet on his ground and all that stuff. And yeah, it's pretty interesting.
So I'm just did you call things? His comment about he read the data sheets. Oh, I can't read data sheets. I skim them to find what I need, but they are the worst written documents. There you go. Someone needs to reinvent the data sheet.
Yeah. So I wrote like a driver for the TMC 5160, right? So and that's like a 150-page data sheet, which is written by like a German company. So it's obviously very detailed, right?
Right. Yeah.
And you see in the data sheet that this is something that has been worked on over time. Because like after you read like 80%, I come to like this one single page where they kind of have like written down. It obviously is something that they're just stuck in there, but it has the commands or the register settings that you need to do to set it up, like the minimal things you need to do.
Right.
So you can basically just copy that and just send that, and it'll work.
But they put it page 80, not at
yeah. So
right.
Basically, I just read everything, and it's like, wait a minute, I'll just send this and see if it works. And it's like, wow, it worked. It's like, okay, I think like maybe the data sheet should be written like this, right? So it's like this. So in order to get this small specific thing to work, you only need this. Yeah.
All electronics data sheets should have diagrams with people with tools and pointing and do this.
Yeah, but it's like, I think it's like a black art, right? To write drivers, like, or just to read data sheets and just have this work. Like, let's be honest, that's like, at least at the beginning, like most of the stuff I did was like, okay, let's find something that already has drivers, or have everything pre-made, and I'll just work with those parts.
Right.
And obviously there's a lot of stuff that Adafruit has done as well, which you can basically just copy. But the freedom that you get when you are actually able to just read the data sheet and just make something from scratch is like unbelievable. It's like
absolutely. And it's also it's a barrier, or it's a time barrier to get into where you want to go.
Yeah, that's for sure. And the problem is that it's like nothing is working until it works, right? So you have like 100% failure rate until that time when it starts to work. And if you don't get it to work, everything is like almost wasteful.
Yeah. Like if I'm looking for something and I find a particular part, and the first thing I will do, if it's a part I've never used before, is I will go look online and see if there's an Arduino driver for it.
Exactly.
Python driver for it.
Yeah.
Python driver for it, right?
Yeah.
And I won't discard it if there isn't, but I'll prioritize it if there is.
Mm-hmm. Yeah.
Or if the part is for something I want to experiment with, and I have to also write a driver for it, then I know that I'm never going to get to experiment with it, because the writing the software bit for me always gets left to last, or never happens, never gets finished, right? But you're right, that kind of limits you into what your choices are and what your freedom is, because then you've only got what someone else wrote as a driver to work with. And most people do the bare minimum. When I started playing around with the time of flight sensors that I've got on SAM, all the drivers that are out there didn't even implement half of the features that are in the data sheet.
Yeah, exactly.
Just implement the bare minimum to get it working, to get a reading back to say, hey, this is 10 millimeters away. But you look at the data sheet and there's stacks more functionality, and calibration information, everything else. But at least you've got a starting point. I'd much rather start off with a starting point than have to invent the whole thing from scratch.
And it's also what I find interesting with this data sheet is like when you don't come from the industry, you don't know all the different words, because there's like a bunch of data sheets which basically could be saying the exactly same thing, but they use kind of different words for everything. And if you have a long time in the industry, these two things basically means the same. And then if you would just knew that, it would be a lot easier. And then that is because just looking at code and drivers, which is kind of like a universal language, right? It makes a lot more sense, right? Because then you don't have to care a lot about that.
If you've got experience working with those things, though, like looking at drivers for hardware, when you don't have, like, even if you've got experience coding, but you don't have experience with how drivers work, that's very hard. It's very hard to look at like driver code. Like you look at drivers for Linux, right? And when you don't understand how drivers work and you try to read it, it's like a complete mess. Like there's very little correlation between that and general programming. But I feel like, though, that like data sheets today are just like digital versions of what data sheets were back in the day when they came in books from companies, right? And they haven't really, like, they have evolved. Like everyone's saying that the RP 2040 data sheets are kind of I think it's different. I wouldn't call them data sheets. The Pi Foundation have made a really nice document about working with the RP 2040 and covering its hardware. That's a manual more than a data sheet. Like I'm talking about an actual data sheet, like the general, 1 to 10 pages, right? They have not really evolved. They've not evolved in the layout. They've not, you still have to scroll all the way to the end to see all the packaging information and the part is an A3345 XYZWPT -TR blah blah blah. To find out what all those things are, you need to scroll all the way into the database and to the data sheet and this big table and try to work it all out. Like they're all the same. They're standardized, but they haven't evolved, right? Where you can't find the information you want first. Like they've all got the typical application diagram. And the typical application diagram is unused in 90% of the applications. Like, why not give us application diagrams, how it's actually going to be used, not, it's like when you look at an antenna data sheet, they give you an example application diagram of here's the antenna on a test PCB that you would plug into your spectrum analyzer to characterize it. Okay, great. I'm not building a board that I plug into my spectrum analyzer to characterize it. I'm building a microcontroller board that's got an antenna on it. How about give me diagrams and application notes and information that correlate to this is how you use it on a PCB. These are the things you need to look at. Don't put things like this near it. Don't put, they show a picture, say orientation, this way, good. This way, not as good. This way, bad. This way, worse. Like, in relation to what? That's great if your board is this big. What's if your board's this big?
Exactly.
Like, anyway. It's fun.
But it's like it helps a lot just by looking at other designs, right? Just like see how things is done. And there's obviously a lot of things which is important, but not necessarily in order to get it to work for your application, right?
Jake says some manufacturers give great. In fact,
I think so too. Some do.
Most don't.
Mostly. But if you just compare them to each other, some are really good and some are like really bad. But what I find, like the way that really changed something, like this is also goes back to what we talked to about, like learning things from scratch. So like what I did was like, okay, so if I'm going to communicate like something like a piece of data, how am I going to send it, right? And then you can start to think about like, oh, okay, so how did they signal stuff back in the days? So like, oh yeah, you could use like smoke signals and all that stuff, right? Yeah. And then you can kind of get into that. And if you just start to just, if you just make the stuff, if you just try to make a communication bus or of any kind and just hand code it, you're going to run into all of the same problems that people have been doing fixes for.
Okay.
Yeah, those kind of things always work, right?
Yeah.
Like it's like, and then you kind of like you need to. When you kind of get that knowledge, it's like, okay, so for how long am I going to have it to be, have a high value, right? If I have like, or how long should it be a low value, and all these things, and you can try to, if you try to build something like this on your own, you will, as I said, run into the same problems that is fixed already in the industry. But when you learn it like that, you kind of understand universally how it works, right? So then you can understand quite easy how, like how an SPI bus work, or how an I2C bus works, or it's just like the same thing implemented in a different way. And when you kind of see it like that, it's a lot easier to understand how all these data sheets work and how the communication work and that stuff.
Right, but that takes time and knowledge and experience and confidence and all those things, which is fine for those that have been working with electronics for a long period of time and whatever. But with so many new people coming in, and so I get asked, one of my most common questions, like on my Discord or by email is, which pins on my Tiny Pico can do PWM, right?
Mm-hmm.
Well, you open up the data sheet and the information's in there. The answer is pretty much any pin, right?
Yeah.
Or which about UARTs. Like I made the video, like every time someone asks me about, how do I, RX and TX, why is it not exposed, blah, blah, I point them to my video, right? It's like but these things are in the data sheet and they're very clear. And even I got to give Expressive credit, like their data sheets are easier to read than most others I've looked at when it comes to MCUs, at least for finding that type of information. They put them in big tables and it's near the start, and they add every type of functionality that every IO can do. And they, but the fact is, all these people coming into this space, none of them know what a data sheet is, or don't know to look for a data sheet. Or when I say to them, hey, look, you can just go check the data sheet, which pins can I use to wake up the Tiny Pico from deep sleep? Well,
Yeah. It's like I think like the most qualified people to write a good data sheet is people which are beginners, right? Because they're not going to use like weird words or stuff like that. It's obviously going to be really hard, but many complex things is really not that complex. It's just that we don't know the words for it. So if we just explain things with concepts and things that we already know,
right?
It's quite easy. But there are mostly experts writing data sheets, and that's who they also write them for.
That could be solved by having a one-page summary at the start.
Yeah.
And I know that says this chip is really good for using in Walkmans and Discmans and low power, blah 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 blah. No, what about what are the most common asked questions when it like you look at the ESP32 forum, yeah. You go through the forum and you look at the most common asked questions, and you answer those on the first or second page in a summary on the data sheet, right?
Yeah.
That's
it is. But the thing is that's what it's because there's like a feedback mechanism back to the people who actually have the possibility to change this, right? And this is something Expressive has solved, I think, pretty good. But if you look at bigger companies, like the feedback from the users with an actual problem to the people who can actually fix things, it's not there, or it's just too long, or they're just working on something else. And because things are really big in really big companies, this will never be fixed, right? But it's not that big of a problem because it's mostly experts doing it.
Right. or other experts. And when you speak to people and like someone tells me, oh, the Nordic documentation for the blah 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 is really good, and I look at the documentation and it's not. It is if you're totally experienced and an expert and you've read all documentation like that before, and you could go, yeah, this is actually better than these guys, and we've got more details and blah blah blah. But for anyone else that hasn't got the experience, you look at it and go, wow, this is just intimidating, and I don't know where to find anything in here, and why do I have to read all this stuff about all this stuff to just find out how to use it? Like,
yeah, it's the same. I think like Wikipedia has the same problem when you have experts hijacking things to make it right. It's like they need to use the right grammars and stuff, and then when you read about something, you don't understand anything about it because it's just too complex to understand it, right? So what you probably
it's different because most people who don't understand what a wiki is assume that everything they read in a wiki is absolutely factual and correct, when a wiki is not. It's just
but that's like but that's not what I'm thinking about. I'm thinking more about like when an expert describing something, he's using expert words, right? And when you're coming from outside to read it, you're not going to understand it unless you're an expert. And then when the entire task Wikipedia is solving is helping people to understand things, it's not going to be useful if it's written by experts. Like the ideal Wikipedia would be written by like a 5-year-old, like a 6-year-old, right? So if you would take like the vocabulary of like a 6-year-old and rewrite the entire Wikipedia, it would be like 10 times as valuable, because it would be a lot more easy for people to understand.
Sure. Yeah, like I think there's a lot of things that could be improved in this space, from manufacturers and stuff, like giving up more information and making it easier to find and understand. And like I'm a big supporter of Snap EDA. For those that don't know, everyone's heard of Snap EDA. I hope everyone's heard of Snap. If anyone that does any PCB design, like they're making a really concerted effort to work with manufacturers to make sure that their products have proper footprints and symbols and stuff. So they're trying to build a good place that you can grab a footprint for your package or a device, stick it in, and it's going to work properly. And they're working with the manufacturers to encourage them to give up all of this data that they normally hold on to make it more accessible and available.
Yeah. Let me ask you something, which I try to remember to ask you about. So this is going to be like a topic shift, but it's still within electronics. So when I said to someone that you'll be assembling electronics at home, people are going to like, I really don't think so. Like it doesn't make sense, right? Why you're saying that you're supposed to have like parts at home and then assemble them? Like, why? That is a lot cheaper to do in like a factory, and obviously with these machines, like there's no way this is going to happen. And then what I find interesting is like if you look at the entire kind of pipeline of electronics production, and if you see the different costs in the cost versus risk, right? In each parts of the process. And if you would look at that and say like, okay, so at what part do you have like an absolutely humongous entropy increase in terms of your parts? Or to use like other words, like where are you kind of the point of return where components on a reel or in a bag are almost impossible to get back, right? And that is at the soldering process, right?
Yeah.
So when a product has its parts soldered to the board, it's like really, really hard to get it off, right? So and because of that, that's where you have like the absolutely highest risk change, right? And if you have like, let's say that if you have like 150 parts, I bet that you could make like 80% of all of the Adafruit products, right? Because there's just so many common parts, right?
Yeah, but no, they've got a huge range of products, dude. I don't think so.
Yeah, but like,
like 1,500 parts, but anyway,
it doesn't need to be like completely true. Like it's like obviously it's not completely true that it could be at 80%, but like I'm trying to prove like the point, right?
You look at all their designs, they will always use the same regulator, 3.3 volt regulator. They'll always use the same diodes. They always use the same, well, passives is interesting, right? Like, there's just general jelly bean capacitors you put on your different decoupling and stuff, right?
Yeah. But some of the passive components are so cheap that it don't even count, right? It's just
they count in space on a pick and place machine, right?
It does, right? But it's like when you have it in like a rotational cassette, that's not going to be a problem, right? So
it's not the cost of the. Oh, right. I see what you're right.
Yeah, because this is a problem you have in the industry. It's not a problem that you would have it at home, right? So if you would spend €100 or $100 on passives, you're going to get a lot of passives. If you think about if you only make stuff for yourself, right?
Yeah.
And then you have like the semiconductors, which is mostly the things that drive the high costs, right?
Yep.
And then also you have like high voltage stuff is also pretty expensive, but there's a lot of products that could be built with this. Okay. So, and then you have
Did you say you're going to ask me a question? Is this all leading up to the question?
Yeah. So would you do you see it the same way as in terms of like the point of kind of no return is like when you do the soldering?
It should be the point of no return, but it's not, because so I've been discussing with Kyle, who I had on stream a couple of streams ago, about we've been discussing failure rates, right, in production, and how much stuff needs to be reworked and whatever. Mm-hmm. And he made the comment that they don't do inline testing of products for their customers. Like they'll test one or two off the batch at the start, and then they just run the project and send them to the customer, right? The customer will test or do what they need to do there, and that their failure rate is very, very low. It's like 0.5%, which is pretty low, right? Mm-hmm. And I said to him, and I have to define what failure means. My failure rate is more like 3%, right?
Yeah.
2.5%. And he went, wow, that's like really, really, really high. Now, I class a failure rate for me as anytime I need to do anything to the board to make it work. Doesn't mean exactly. It's a test jig. Right? It could be just a decoupling cap that isn't sitting right. It's tombstoned, or it's just it's sitting a little bit proud on the pad. I need to just put a little bit of flux and hot air and rework it down. Now that board would still pass the test jig.
Yeah.
But might fail out in the wild because of decoupling, right? Noisy power source, whatever. But I would still class that as anything I need to do work on that is a fail.
Yeah.
And he kept saying to me, that's too high, it's too high. And I replied with, says the man that's got an automatic stencil printer, fully automatic stencil printer, a second-hand but full-on commercial pick and place machine, right? And a commercial reflow oven and optical inspection and everything else, compared to me, who's manually stencil printing. I've got an okay, but a Chinese, pick and place machine that, definitely hits above its weight class, and a, Iron 6 reflow oven. I mean, I'm bound to get more issues for what I've spent on my line than what someone else will. So in my case, it's not the point of return. It's because I have to often tweak and rework boards. That's part of my process.
Yeah.
If I want to not do that, I need to spend a lot more money on equipment.
Yeah, right? I think like the point of no return is probably like a bad choose of words. So let's say like where it's like if you have a bottle and you break it and it shatters, right? It's pretty hard to get it back in shape. Sure, or it's pretty hard to get toothpaste back in, right? Because you have like a very high increase of entropy. And if you measure the different steps, I think it's like it seem to be similar to this in electronics, right? And I'm thinking like, do you want to store bread or do you want to store flour, right? If you make bread out of flour, it's going to be, it's hard to store it. It's gonna rot. all kinds of issues. But it's quite easier to just store things as flour because
And make the bread if you need it, right?
Yeah, exactly. All right. So you could have like a bunch of components, and then maybe like some new semiconductor stuff shows up, and suddenly someone makes a product of that. You can actually make that. So I find this interesting. Something else which is really interesting, I think, is that I'm like, I obviously live in in a pretty rich country. Yeah. So yeah, obviously that too. A cave in a rich country. And at least where I'm seeing is that I find it pretty interesting that if you look at DigiKey and all this, not all of them, but there are not many shops. There are like 3 or 4 big shops, right? And tell me, what industry can you order stuff from and spend like $30, $50, and you'll get free shipping overnight almost, and you'll have it after 3 days, right? It's like, it's absolutely bonkers. And the reason it is so, it's just that they're just sending a lot of packets, sending a lot of stuff. And
but it's also a really competitive marketplace, right?
Exactly. So that's my point, right? So if you probably don't need to store that many parts, right? Because if you look at the $50, it's not that a lot of money compared to what general products cost, right? Most products which are made of electronics costs over $50, right? And you could order them and you'll have it at your door after 3 days.
Yeah.
So this is pretty interesting because that means also that you don't need to store a lot of stuff because you can just order it and you just have it pretty fast.
Right. Well, silicon shortage time aside, like I used to build all my stuff on demand, right? Like
Exactly.
I don't sit there and build thousands of tiny picos and have them sitting on my shelf in case I get a big order through, right? I might build 150 at a time on my shelf and they eat away. And then when I get orders in, I build them as I need them. That's become harder with the silicon shortage because I've had to invest a lot more in parts to make sure I've got parts. I still build on demand, but I'm investing a lot more money at a time in, making sure I've got lots of reels of, flash and RAM and crystals and stuff, all the things that are expensive right now. But generally, yeah, being able to order parts, like often I'll get the parts before I get the PCBs.
Yeah.
I'll be waiting on PCB or I'll be waiting whatever else. Owning, all the passives, even in different sizes, is not expensive, right?
No.
But it's the other components that are.
Yeah.
And they're the gamble ones. How many do you buy and whatever. Like I'm buying, my LDOs now like 15,000 at a time, like right, because I just can't run out of this LDO, and I use it across all my boards, and I even use it on boards that I probably don't need to use it on. I could use a completely different LDO, but it doesn't make any sense for me to stock 2 types of LDOs when they're really hard to get right now. I might as well
exactly. Right? Yeah, but but still, semiconductors, even though they are expensive now, if you look at it as from like how close to the value chain you are when you just assemble them yourself and just use it in your own product, semiconductors are pretty cheap, right? Even like so.
If you're building small amounts of things.
Yeah, exactly, right? So. So because like it's not necessarily that the margins are so so great on electronics. It is, but it's there's so many things to factor in when you make electronics that in the end the margins are pretty low, right? But when you kind of assemble things at home, you can I like, to me, I see these kind of parts that you're talking about as the parts that actually define the product, right? So it's either like if it's a sensor, sensors tend to be pretty expensive, and that's like the main cost factor. But that is also going to be like the thing that defines what the product is. So you don't necessarily need to stock those kind of parts because you can just, they're expensive enough to just buy them. Yeah, that's it. Yeah, exactly like Marius saying. It's like this is absolutely insane, right? I ordered stuff from. Right? Yeah, I ordered things from Texas Instrument that I got after 24 hours.
Yep.
And the cost of transporting it is the same as the cost if I send like a package like 10 kilometers in my country,
Right.
and that takes like 3 days.
Yeah.
So it's like,
no, you're right. It's and that's what makes it great about being in this space, right? Where where the information is readily available and the components are readily available, and the software support is readily available, and there's a huge community out there to help, right? It's never been a better time. Like,
yeah, and this might be like some colonialist thinking in me, but there's like, if you have like someone who lives in a pretty poor country, right, and they have the ability to put together, let's say, like a fever meter, like to measure your fever, like a temperature, right? Like almost any semiconductor companies have these kind of products almost done, right, as reference products, right?
Yep.
So someone who lives in this kind of country could just like download something like this and just assemble it and start to sell it, right? And that I think that is like pretty interesting, because and also it's like you could never do that, like legally, at least, like in my country. But in countries which has less regulations, or where generally where government doesn't have that much control, right? They have like an absolutely insane opportunity to start to selling these things. Just they could just like take the reference products and start selling them. And that would be, I think that's like really interesting, because electronics has like a very low cost if you're able to make it, and if you don't care that much about things coming in a nice white box which smells nice when you open it and all that kind of bullshit. Then you'll get the product, and you're able to use the value of the product. So that's also something which really excites me about like working with this stuff, and why I find it like really motivating to just make stuff out of simple and accessible stuff, right? Because making stuff out of professional stuff is not hard, right? That's just like basic engineering, just like taking things that we know work and just put it together, and so that's obviously something really interesting. And then you also have like all of these problems with approval, with governments, and import restrictions and all this stuff. Like when you put your board together, it becomes like a product, right? And
sure.
I get
not
there's
everyone
been
has to sell it. Not everyone, like the fact that people can just make it is great. Like it's motivation doesn't have to always be about someone selling it.
No, it doesn't. But if you want to do that, it's possible, and it's probably not as interesting for us which live in pretty rich countries, right? But I think it has like a good. I'm not sure.
If you move to Melbourne, you're gonna get stuck in your home for a little while.
I heard that it's almost impossible to move to Australia. Like
right now, it's impossible because our borders are closed. But yeah.
It's also pretty hard to get here now.
Sure.
Yeah.
Sure. So Mark was complaining that Melbourne to Sweden is 3 weeks, but he ordered something from the UK and got it 16 hours. Right. So just to let you know, I mean, it's not just Melbourne or Australia to somewhere. Like I ordered, so my cameras I ordered 2 weeks ago that Singapore still.
Oh yeah, it's crazy.
That I haven't left because they can't get a flight into Australia. This is DHL. Right?
Yeah.
Like my average delivery time now for DHL is 12 to 15 days. It's ridiculous.
Yeah. So here's the thing. There are certain kind of building block products within electronics that should be built, right? So like the existing building blocks of like the makerspace is like the ESP32i camera thing, right? Everyone is building using that camera to do all kinds of maker projects, right?
Not me. No.
Yeah, but people who make those kind of stuff, right? And that uses like the OV2540 sensor, which I think it came out in like 2004, right?
Yep.
And everyone is like running top of the line machine learning applications with this, and it's like they're using like this absolutely old garbage camera. But it has one advantage. It has like an built-in processor, right? So it makes it possible to make some really small and simple designs. But this is where yeah, it is. But all cameras are cheap usually. Well, obviously it's going to cost 10 times more but it's still not a lot of money, right?
Right. So like a 4K autofocus camera, the one of the cameras I've got, which was, $54 or whatever it is. No, $49, right? For a 4K autofocus camera, USB camera.
Yeah, exactly.
That's
right?
insanely cheap. I get that. But when
Yeah.
you talk about electronics and you say, I'm going to build a project and one of the components is $49, like
Yeah.
here's a $5.
That's not like insane.
Right. So where those little OV, whatever the model number is, like you can pick them up for like $3.
Exactly.
Right? And
yeah. That's probably because they're still made in Shenzhen somewhere, or like still falling out of trailers.
Right,
yeah, but like back to my point, it's like there are certain products that could be used as building blocks, right? So there should be like an open source project to make like a proper camera, which is not like the might be bus camera for the Raspberry or stuff. It's just like a USB UVC standard, uses webcam. It has like a decent sensor, and everyone can just start to use that. And then you could do the same with other things, like I would call like the ESP32 or like all of this these boards, the stuff that Adafruit makes, are mainly like building block products, right? Which you can build other stuff off. And there should be more products like that. So that's like where I'm interested to build like these motor drivers, right? Because there's like the only motor drivers that exist now are like the Polulu derivative, which is like the small tiny boards which go on grabbable controllers, right? Which is like, why do you have to do it like that? And there are some products which probably are more valuable for more people than others. And I think there's like a great potential in working with those kind of things. Yeah.
It's about finding the thing though, and what your motivation is for making it, Like, is it there's a maybe there's a niche here, I could exploit that and make a lot of money, or maybe there's an opportunity here where I could make something that's easier for people to use, right?
Yeah.
I mean, they're really opposite ends of the spectrum, and the ones that start out with the maybe I can exploit this tend to fail more often than the other ones, I think.
Yeah. It's like if you look at like the Brian's USB-C product, right? Which you use power delivery.
Yeah, the FlexiFriend. Yep.
Exactly, right. So that's like a building block product, right? So the reason is that you can get 19 volts out of it, and you can get a pretty decent power to run almost anything out of that, right?
Yeah.
And it's made of almost no parts, right? And I have bought like all of the evaluation kits of USB-C to use power delivery, and they all have a lot of parts, right?
Yeah.
Because they are supposed to work in all kinds of applications.
But pass the USB specifications to be certified.
Yeah. But like what is great with this is that, so what does it do? Well, it replaces like a switching power supply, which is like a very big chunk. I mean chunk, not junk, like a piece of hardware, like in really advanced stuff, like this very small chip with a few passives, right? So you could probably run most 3D printers on this. It's enough power, and you can use like a USB PD, a very safe converter.
Sure.
From getting it down from mains, right? So I think I really like this product, and I bought one from him, and it's gonna arrive soon. I'm probably gonna use it in like the machine I'm building.
I got the same thing like now. Like as I said, I'm working on my automatic turntable, and I'm trying to get everything working at 12 volts instead of 24 volts. So I can use USB-C to power everything with the power, using a power delivery chip. But the fact is, I can buy a little switch mode wall wart power supply for like $9.
Yeah.
12 volts, 5 amps, and I'm going.
Yeah.
Damn, I'll just plug that in instead, right?
Yeah.
So it's how many people are going to have one of those compared to a way of delivering USB-C power, right?
Yeah, probably a lot, but it's really small, and it can be made like parts of like smaller, like really smaller machines compared to like this big bulky stuff. And most people don't have these switching power supplies, right? Like there's like so many people are like afraid of getting them, right? Because they're like everything which has to do with mains seems to be very dangerous.
Sure.
At least it looks like that in 3D printing groups and stuff.
Well, the problem right now is you can't get the power delivery chips at all anywhere. Like they're just out of stock everywhere.
Yeah, it's like, but like, how hard could it be to just like capture the handshake process and just like
do it yourself?
Yeah.
Dude, USB is complex. You need.
Yeah, but it's like you don't even need to know how it works. You just capture it and just like ghost it and just like, yeah, this is what needs to be done. If you just read it with your logic analyzer and just capture it. In my head, I'm thinking this should really work. I should just really capture this data, just like, and it's gonna work. But maybe not. But
if you read
at least it's worth trying.
Have you read the 3 and 3.1 specs? Oh my god, it is like 100 pages of
junk. No, yeah. But that's the point. Like, but that's what these Chinese people did, right? They just took out the bare minimum, and it's like, this chip is probably like the nightmare chip to use in like a proper product, so to speak, right? Like a Western product, right? Because there's so many things that could go wrong.
You wouldn't be able to get USB certified with them, with most of them.
No, but like, who cares about the certifications, right? Like, but like, if you're going to sell a professional product, you do.
Right.
But if you're going to have a product that you're going to just use yourself,
that's a different story. Absolutely.
It's that's like another thing which I think is going to also fuel this. Is that's like all of this certification stuff, which is like, I would say, like, if people would take just more responsibility of the product they buy themselves, we could have quite a different world instead of just trying to have someone make everything safe for you.
Right. Yeah. Let's not go into certification discussion. That's I do that a lot on my channel, and I think people are. But yeah, no, you're right. It's politicians that decide certification rules, not. Anyway, let's not.
Yeah, I'm not saying it's not useful. It's just that it's not useful for all cases, right? No. Everything is there for a reason, and it's usually a pretty valid reason.
Yeah, it's definitely overdone. Marius, listen, we've been going for quite a while, 2.5 hours.
It's like a new day here now.
Yeah, sorry. Well,
so I arrived in the future with you.
Lots of the chat need to go to bed, and I need to get to work while I'm at work.
I need to go to bed.
Yeah, sure. It's been great having you on. Thank you very much. Really enjoyed the chat.
Yeah, thanks for bringing me on. It's like pretty cool to usually just watch your stream, and suddenly I'm here, which is kind of bizarre, but it's been
very
fun.
Quiet in the background. You're a quiet achiever. No one's like, you don't even promote yourself or show much of what you've been working on, and I'm glad you're going to be changing that. So everyone subscribe to Marius's channel.
Yeah, please do that. Please do that. That would be cool.
And you're on Twitter as well, aren't you? Did I put the Twitter link in the description?
Yeah, I'm on Twitter, and I also converted like my Instagram to like a professional thing, so I can post stuff there. So it's something I really like with Instagram is that just like point and shoot your mobile. And it's nice to keep people updated on small things that you don't necessarily want to make like a complete video about.
Yeah, for sure.
Yeah.
So I've got my other unexpected streams channel, which I've done nothing with, like YouTube channel. I might start doing, like you were speaking about before, just some ad hoc, random-y type. Start the camera rolling while I'm working on something, just random trash on there. So we'll see.
Yeah, I think it's like if we should have taped like some of the stuff that we did with like the thing. It would be useful for someone.
Oh, absolutely. I would have. Yeah. I should have like recorded or live streamed my design stuff for my vacuum big. So I went through a lot of different iterations, and probably would have been interesting for people to look through all the different designs I did. Yeah.
Yeah, but it should be kind of junky and not good, because or else you're gonna care too much about the optics of it, and then
no editing, just stream.
Yeah. Yeah.
Yeah, swearing, everything, the works.
Yeah.
Yep.
I don't swear.
Yeah, I do.
Okay. I swear.
Yeah, okay. Cool. Okay, Marius, thanks.
Okay.
Thanks, mate.
Yeah.
Everyone, thank you for joining. And if you've got any more questions for Marius or for me, put them in the comments on the stream, and I'll get back to you. And hopefully Marius will look through the comments as well. And because there were lots of questions that went past that maybe Marius didn't catch.
Yeah, I'll catch them. You can also just DM me on on your Discord.
Yep.
Yeah.
Cool.
If there's anything, and again, appreciate it.
No worries, mate. No worries. Thank you.
And
Take
just
care, everyone.
Okay. No, I was just going to say that I think I'm just so grateful that you have started to document your journey and do all of this stuff, because you're such an inspiration for anyone who's doing this.
Oh, stop it. You're going to make me blush.
Yeah, but it's true.
Thanks.
I'm not saying it to be nice.
Okay. Okay. Not saying
Okay.
to be nice.
Yeah, okay.
Mean. Yeah.
No, it's just true.
Okay. Thanks, buddy. Thank you. Appreciate it.
Okay.
Okay.
Okay. See you.
Bye.
Bye.